This is lecture 4 on energy. So this is section 6 of an AP chemistry course. So in this little lecture, we're just going to talk about the system. And the system is the product and reactant molecules. You can just view them as trapped in a little volume. So the first statement I make is going to be completely true always. You should just try to remember it. I don't run into too many people that seem to know this very often. So the energy of bond making and bond breaking. So if you have a molecule and you break a bond, the minute and every single reaction has to have these processes. So that's why these statements are important. Anytime you break a bond, it requires energy. So that's an endothermic thing. So in the middle of the transition from reactants to products, you're always breaking bonds. So you have to have a bunch of energy input just to break all these atoms apart. And that energy has to come from someplace. That's why some reactions don't work so well. And then bond making always releases energy. It's exothermic. So in any chemical reaction, when you transition from reactants to products, you have both endothermic and exothermic portions of that. And it's all within the system itself. That's not any energy flow flowing, outward or inward from the surroundings yet necessarily. That's just like what has to happen in the system. Um, and so the sum of those two processes determine whether a reaction is endothermic or exothermic. Um, Sometimes some of that energy can come from well, it has to if you're going to break those bonds. But anyway, that's a process that happens within those molecules. Okay, so now the second thing is chemical potential energy in reactant molecules versus product molecules. So there's a potential energy, just like some of you probably know that there's potential energy. If you raise a brick above the surface of the earth, you store potential energy. As you move these charged things towards and away from each other, you store potential energy also. So that chemical potential energy stored in these molecules is what's coming out when you have an explosion or something. So it's stored in the electrical fields that are within those molecules. So you can also view the energy flow during a reaction as a comparison of chemical potential energy in the products versus the reactants. So it kind of makes sense that if the products, so I'll follow this. So this CPE means chemical potential energy. If the chemical potential energy in the products is greater, well, that energy had to come from someplace. So that's going to be an endothermic reaction. So energy had to flow into that system. So if your products have greater potential energy, that energy has to come from someplace. It came from flowing into the whole system. And that makes an endothermic reaction. So if the reactants have less chemical potential energy and the products have more chemical potential energy, that's an endothermic reaction. And then if the chemical potential energy in the products is less, this is an exothermic reaction. If reactants have more chemical potential energy, then when they fall, or whatever we're going to call it, it's equivalent to falling. Energy comes out, because if the products have less potential energy, there's missing energy. That energy flows out of the system and makes the reaction exothermic. Okay, so then there's a third way of viewing this, and this is why these things get a little tricky. So you can also view this stuff in terms of bond strengths and chemical potential energy. So you can classify reaction energetics in terms of bond strength also, because bond strength is directly related to chemical potential energy. So this is kind of an odd relationship for people at first. So if you compare two bonds in a chemical reaction and the product bond is weaker than the reactant bond, this will be an endothermic process. And if you compare two bonds in a chemical reaction and the product bond is stronger than the reactant bond, this will be an exothermic process. And so you can just think that through a little bit, but I'm just going to make some general statements at the end. So, an endothermic reaction, the chemical potential energy is greater in the products, and bond strength is less in the products. And in an exothermic reaction, chemical potential energy is greater in the reactants, and bond strength is greater in the products. And so, in this weird sense, we'll talk about this next lecture. Weak bonds are associated with high chemical potential energy, and strong bonds are associated with low chemical potential energy. So if you have two things that are very strongly bonded together, it's hard to get energy out of that because you're going to have to put a lot of energy in to break the bond. So how are you going to get energy out if you have to put this tremendous amount of energy in? Is a difficult thing. But generally, you should just kind of think weak bonds have high potential energy and chemical potential energy, and strong bonds have low chemical potential energy. Thank you.